Welcome to the exercises solution of mathematics for class 9th, new syllabus, latest edition 2020-21 KPK textbook board Peshawar. In this tutorial we will start our next chapter, chapter number 2, which is about the real and complex number. And in this tutorial we will solve the questions of exercise 2.1. But before going into the solution of exercise question, let's discuss some background which is about the real number. So let's recall about the real number. That see, we have different types of the number in which we are categorizing them in different classes. So first we have the rational number. Okay, so a number which is expressed, the number that can be expressed in the form of P over Q, that is called the rational number, where P and Q will be integer and Q will be not equal to 0. It will be non-zero. For example, we have 3 by 4. Okay, for example, we have 4, as we know that there is 1 is a denominator, so these are the rational number, and the set of rational number is denoted by Q, mean Q is the representation of the rational number. Then we have another set of number which is called the irrational number. Okay, and that is represented by Q dash. Okay, consist of all those number which are not rational. See, mean those number which are not rational, for example pi, for example under root 3, these are the irrational number. So the relationship between the various set of number is, see, we have all numbers are called the real number. Okay, then in the real number we have two category. One is called the rational number and second one is called the irrational number. Okay, mean the real number is divided into two categories, real number and irrational number. Then we the rational number and irrational number. Then we have the two categories of the rational number. One is called integer. Okay, and second class of the rational number is called fraction, that is called fraction. Then again in integer we have positive real number, we have 0, and we have negative real number, negative rational number. Okay, then in the positive rational number and 0 rational number, that is classified into different classes. One is called the whole number, second one is called the natural number, then we have the even number, also we have the odd number, and we have the prime number. Okay, so this is the classification or categories of the real number. Then we have again representation of the rational and irrational number in term of decimal. So every rational number can be written as either terminating decimal or repeating decimal. All terminating and repeating decimal are rational number. For example, if we have 1 by 9, so it will be equal to 0.111, and it will be, we can say that it will be recurring, and it can be also written as 0.11 bar. The bar means that the number is repeating okay, forever. And for example, if we have suppose 3 by 8, so it will be equal to 0.37 and 5. So it is terminating number. So the rational number will be either terminating or it will be recurring. Okay, so this is also one of the definition that all those number which are terminating or which are recurring, they are called the rational number. And then we have the irrational number. Okay, for example, if we have under root 7, so under root 7, if you open it, it will be equal to 2.64575 1 3. It is non-terminating and non-recurring number. Similarly, we have pi, which is equal to 3.1415927 and so on. Again, there is a non-recurring and non-terminating number, so that's why it is called an irrational number. Okay. Then we have a graphical representation of numbers on a number line. See, number line help us in visualizing the set of real number. For example, if we are drawing a line, okay, and we are just depicting a point on the number line. Okay, we are representing the numbers on that and that line. Okay, and the number associated with a point is called the coordinate of that point on the line, and the point is called the graph of the line. Okay, see, we are just drawing a line with the arrows because the numbers are not ending, and at the middle of the line we are just take a point which is called 0. That is the we can say that origin of the graph, that is the center of the graph. Okay, and to the right of 0 mean in the right direction, in the positive direction, we have positive number, mean this portion will be divided into equal part. Okay, this portion will be divided into equal part, and it will be 1, 2, 3, 4 and so on. These are called the positive number. And to the left side and to the negative direction, again it will be divided into equal parts, and it will be -1, that will be -2, -3, -4 and so on. Okay, so in order to draw a real number line, we first draw a straight line and label a convenient point on the line with 0. Okay, that will be a type of center point, and then in both direction we are labeling the points at equal distance, and to the right direction it will be positive number, and to the left direction it will be negative number. Okay, then we have the demonstrating a number with terminating and non-terminating recurring decimal on the number line. Okay, if we have the non-terminating recurring number, or we have the terminating recurring number, so how it will be represented on a number line? See, there is an end to the division process when we divide 1 by 8. Suppose if we divide 1 by 8, so we will get what? 0.1, 2 and 5. So the number will end. Okay, so therefore this number is called the terminating decimal number. Some number, for example, if we have 5 divided by 7, so it will be equal to 0.185185185. Okay, that cannot be written as a decimal with a finite number, because this is a recurring number, this is a non-terminating number. So but result in a number of digit that repeat infinitely. Okay, mean that is not non-terminating recurring decimals. Okay, so then we have to represent it on a number line. So we will do some question on it in the exercise. Now let's come to the solution of exercise 2.1. So see, different numbers are given, and in question 1 to 10 we have considering this number and answering these 10 questions, that which are the whole number. Okay, so in the given numbers, see, 3 is a whole number. Okay, under root 36 is a whole number, because if you take the root of 36 you will get 6. And see, 1 is the whole number. Okay, so these 3 are the whole numbers. Which are the integers? So we know that integers are positive and negative whole number. So again we have 3 under root 36, okay, which give us 6, and -9, okay, and 1. So these are the integers. Which are irrational number? So the irrational number will be non-recurring and non-terminating number. So if we look into the number, here we have under root 3, okay, and we have under root 7, and we have minus under root 14, and we have pi. So if you look into the nature of these numbers, these are non-terminating and non-recurring numbers. So these are the irrational number. Then which are the natural number? So natural number are positive whole number except 0. So we have only 3, 36, because it will give us 6, mean under root 36, and 1. These are the natural number. Which are the rational number? See, so rational number are those number which are recurring or terminating or whole number, yeah, which can be written in the form of P over Q. So except, remember, except pi, under root minus under root 14, and under root 7, and under root 3, except these number, the rest of the number are rational number. Yeah, we can say that except these number, because these are irrational. So except these number, the rest of the number are rational number. Okay, which are real number? So we can say that all numbers are real, as we have also discussed in the previous slide, that real number will be either rational or irrational. So all numbers are either rational or irrational. So the sum of the rational and irrational are real number. Okay, so all of the given number are rational. Which are rational number but not integer? Okay, so see, 2.5 is a rational number, but it is not an integer. Okay, it is not positive or negative whole number. Also we have 5 by 7. Okay, we have minus 1.96. okay, we have minus 7 by 6. okay, and 4 2 by 3. okay, and 0.33. These are rational number but not integer. Question number 8, which are integer but not whole number? Okay, so minus 9 is integer, but it is not whole number. Whole number is starting from 0, 1, 2, and so on. Mean the positive integer number along with 0, that are whole number. So minus 9 is an integer, but it is not a whole number. Okay, which are real number but not integer? So see, the 3, except 3. Okay, that is an integer, that is real number and integer. And in the question they are asking that which are integer, sorry, which question number 9, I'm talking about question number 9. So which are integer but not natural number? So again minus 9. Okay, all numbers are integer. Okay, except 9. Okay, 9 is a non-natural integer. And in question 10, see, which are real number but not integer? So all of these number are real, but we have to take out the integers. So see, 3, okay, under root 36, okay, minus 9, 1. These are integer. So the question is, which number are real but not integer? So except 3, under root 36, minus 9, and 1. Except these 4 number, the rest of the number are real number but not integer. Okay. Question number 2, write the decimal representation of each of the following number. Okay, so see, when you divide 1 by 6, so you will get 0.166 and so on. Okay, also you can write it 0.16 to the power mean bar. Okay, it means that 6 is repeating. 5 by 6, okay, it will be equal to 0.8, okay, 3, 3, 3, and so on. Again, that is a recurring number, so you can write it 0.83 bar. okay, that 3 is repeating. 2 by 9, so it is equal to 0.222 and so on, okay, or you can write it 0.2 bar, okay. 1 by 8, that will be equal to 0.1, 2 and 5, that is a terminating number, okay. So these are the decimal representation of the given number, okay. Question number 12, depict each number on a number line, okay. So first you have to draw a number line according to some respective scale, okay, and just take a convenient point on it is a 0 point, okay. Now take the equal take point at equal distances 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So suppose that is 1. Now see, the 1 is divided into 10 part. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, mean from 0 to 1 we have divided it into 10 part. So each part will represent, see, 1 of 10. Okay, so see, 1 of 10 will be this point, okay, that is 1 of 10. Okay, now see, 1 by 4 mean fourth portion of this 1, so we have divided it into 10 part, okay. So 2.5 mean mid of the 2 and 3 point, that will be 1 by 4, okay. Then we have 1 by 9 mean the ninth part of this we can say that of this 1 portion, so we have divided it into 10 part, so the ninth part will be a little bit greater than this 1, so it will be 1 by 9, okay. And 1/3 of this portion, 1/3 of this portion, it will be 1, 2, okay, sorry 1 by 4 will be here, okay, mean that is 1 by 4, fourth portion of 1, and third portion of 1, that will be 1, 2, 3, it will be a little bit greater than third point, so that will be 1 by 3, okay. So this was all about the solution of exercise 2.1. Thank you for watching. Subscribe the channel for more videos. Comment if you have any question or suggestion and share with your friend. Thank you.